In previous lecture, we saw concept of line clipping, and we have solved one example as well based on the line clipping. Okay, the algorithm is known as Cohen-Sutherland algorithm for line clipping. Just we will go through the steps whatever are involved in the algorithm, and according to that you need to perform the operations. Okay, so if you remember, there are 9 regions. Okay, LR by T, that is left, right, bottom and top. Right, left is 1, right is 2, bottom is 4 and top is 8. Okay, so according to that the region codes are assigned in the binary format. Okay, if both the points are lying inside the window, then region code is 0000, and that means the line is completely visible. Fine. So just first step is assign a region code for 2 endpoints of a given line. We saw in the example how to assign the region code depending on the left, top, right or bottom, like that. If both endpoints have the region code 000, then the line is completely inside. Okay, no need to do anything, nothing, no need to calculate intersection points or nothing else. If the logical AND operation for both region code, okay, then perform. If the result is not 000, fine, that means at any 4-bit position 1 is present, fine, then the line is completely outside the window. Fine, line is completely outside the window. Else line is partially visible. Okay, or that means partially inside, partially outside. What you have to do then, in such a condition we need to calculate the intersection points. Okay, choose an endpoint of that line that is outside the given rectangle. Possibly there are both the endpoints are outside, possibly one point is inside, one point is outside. Fine, find the intersection point of the rectangular boundary based on the region code. Okay, replace endpoint with the intersection point and update the region code. Repeat step 2. We find a clip line either trivially accepted or trivially rejected. Like this, the algorithm is very simple. You just need to deal with the region code, or which is also known as out code. Fine. This is for a single line. If a window contains number of line, you need to repeat these steps from step 1, okay, for the other lines as well. So this is one of the example. Fine, algorithm is implemented over here. Number of lines are drawn. Total lines are 6 over here. So whatever outside lines are there, these are clipped, and here the line is drawn from the intersection points. Let's run the code as well for line clipping algorithm. This is the line clipping algorithm. Okay, here is a x min, y min, x max, y max for the window is defined. Fine, according to that the window size is fixed. You just need to hard code it. Okay, that's okay. Then draw the number of lines inside the window. Okay, we'll run it. Let's see how it works. And according to that, first I will draw a window. Fine, window is drawn. Now see, I am drawing the number of lines over here. Some lines you can draw inside, some partially visible, some are completely outside, like this. You can draw a number of lines like this. Fine. Then when I say clip, okay, whatever lines are inside the window, these are visible, and outside lines are invisible, right? According to algorithm. Fine. So this logic you can easily implement in the practical. Okay, according to steps. Fine. Uh, that is about algorithm and implementation part. Now we will see today next algorithm, okay, which is known as polygon clipping algorithm. Okay, so let's start with the polygon clipping. So polygon is nothing but, again, number of lines are involved over there. Yes, and these are connected to each other. You know, the first point and last point should match basically to complete the polygon, right? Then the question is, why can't I use a same line clipping algorithm for a polygon clipping? Yes, can I do that? Let's see. I will draw a simple polygon over here. Uh, just a minute. See, like this, I am drawing a polygon. Okay. You can draw the polygon like this. Okay, polygon is drawn now. Fine. Then here I will select some of the portion. Fine. And I will clip that portion. This is my window. Okay, this is my window. And I just cropped it. See, in the window, whatever part is visible is displayed, no doubt. But what is the reason? What is happening over here? Whether the polygon, whether we got again a polygon? No, but we got the disconnected lines from each other, right? That's the reason we can't apply line clipping algorithm for a polygon clipping algorithm. Fine, I hope you got it. So again, a set of lines you will get over here. Again, if you clip, again, see, I will select this much portion, and this is again cropped. See what you got over here. Again, the number of lines you got over here, disconnected lines. Fine. So let's understand the concept of polygon clipping here. Polygon clipping algorithm name is Sutherland-Hodgman algorithm, which is used for the polygon clipping. Sutherland-Hodgman algorithm. We will understand the concept of Sutherland-Hodgman algorithm as well. Let's start. Okay, we can clip a polygon by considering whole polygon against each boundary edge of the window. Okay, here we are assuming again a rectangular window. Generally the rectangular window is used. Okay, this is achieved by processing all polygon vertices against each clip rectangle boundary in turn. Fine. Beginning with the original set of polygon vertices, we will first clip the polygon against the left, then you can clip to the top, then right, and then the bottom. Like this, we are going to clip the polygon against the window edges. Okay, let's understand what all steps are involved over here. Okay, so there are basically four relationship between the edge and the polygon plane. Okay, four relationships between edge or side of a polygon, you can say, and and clipping plane. Clipping plane, that is nothing but window. Okay, clipping plane is nothing but window. Fine. So let's understand what all relations are involved over there. Here, first relationship I will write here. Fine. Assign the arrows to the edges first of all. Okay, I will show you with the diagram as well, but now first we will understand the concept. Okay, if the first vertex of the edge is outside the window boundary, okay, first vertex is outside, first vertex outside the window boundary, outside the window boundary, and Second vertex is inside. Second vertex inside. Just a minute. Vertex inside the window boundary. Okay, this is the first condition. Then the intersection point of the polygon H with the window boundary and the second vertex are added to the output vertex list. Fine. Which points you are going to save here? Save intersection point, intersection point and second vertex, or you can say a inside vertex. Second vertex are added. Fine. Next, next condition we are going to see now. Okay, what is the second condition again? Let's go for the second condition. Condition is now both vertices of the edge are inside. That is the condition. Second, both vertices are inside window boundary, inside the window boundary. Then which point you are going to save in this case? You just need to add the or save the second vertex. That's it. Save second vertex. Just understand it. We will see with the help of example. Second vertex. Next, third condition. Okay. Here, if first vertex is inside and second is outside, reverse condition of the first. Okay. First vertex is inside and inside the window boundary, and second is outside. Second is outside. Then what you have to save in this case? Save only intersection point. Save only intersection point in such a case. Okay. Let's go to the fourth condition here. Okay. Now both points are outside the window. Okay. Window boundary. Do I need to save anything? Definitely not. Okay. If both vertices are outside window boundary. Okay. Then yes, save nothing. Save nothing. Fine. Just these four conditions we are going to apply, and according to that you will get a polygon again. Let's see how it works. I will draw a simple polygon over here. Fine. And then we will clip it so that you can understand it. Fine. This is a polygon. So okay, instead of this I will do it with the help of lines. That's better. Arrow is there for a line. Sorry, just a minute. Okay. Yes, let's see now. We have seen the steps. According to that, this is a polygon which is drawn in a clockwise direction. Okay, from this point, like this, like this, like this. Okay. Now this is the window we are going to consider. Sorry. window we are going to consider. Okay, consider this is a window, our window. Fine. Then quickly I will give a naming to this. Okay, let's say this is A, B, C, and D. Fine. This is the naming for polygon. Okay. Then if we have selected this particular window, then let's draw from A to B. Okay, A to B, if you observe, both points are outside the window boundary. Okay, so do not save anything in this case. Do not save anything. Now we are moving from B to C. That means one point is outside, that is B is outside, and C is inside. Okay, in such a case, you need to save this intersection point and another point, that is C. So for the PCH, wherever it is intersecting with uh, window, I will name it as, say, intersection I1. Okay, save I1 and point C, point C. Okay, let's move further. Move from C to D. Okay, move from C to D. Both points are inside the window boundary. Okay, both points are inside the window boundary. So save second point. Which one is the second point? Save D in this case. Okay, now you are moving from D to A. D to A. Okay, so again you need to save the intersection point. So this is the intersection point over here. Okay, so which point we are going to save in this case? Save, yes, intersection point only. Save I2. Save I2 in this case. Okay, this is about the algorithm. Fine. So we have saved all the points. Let's write all the points now. I1, comma C, point C. Okay, comma point D, and comma I2. I2. We have collected the points. Yes, just quickly I will select this much portion. Okay, selected the portion. I will move this portion. Okay, so that you will understand. Then from I1 to I2. Okay, or sorry, from I2 to I1, you can draw a line, and you just need to complete the polygon over here. Draw a line from, okay, like this. You have to draw a line. This is the point. This is the point I1, and this is the point I2. Fine. So in this way, again we got the polygon after clipping. Fine. Similarly, we will see one more example for a polygon clipping. Let's see. So, okay, the same concept is explained here. Four possible cases for a given age. If, let's understand with another example. Input of the polygon is 100, 150. Okay, this is 100, 150. 200, 250. This is 200, 250, and 300, 200, like this. Okay, so this is the clipping window, our window. Fine, and this is the vertex list. Basically, the triangle is a polygon which we are going to clip with the help of window. Fine, that rectangular window. So left part is clipped over here. If you observe, left edge of the clipping area is extended to infinitely, and polygon points are clipped using this. Okay, left is clipped properly top edge is extended infinitely, and again the top is clipped over here. Then next, after clipping, okay, how you are going to calculate the intersection point? Same as that of the line clipping algorithm with the help of y is equal to mx plus c equation. Okay, the same way you are going to calculate here. So how many vertex in this case we are going to save? Yes, 150 comma 200 in case of left clip. See, intersection point, if we are moving from outside to inside, intersection point and inside point you are going to say, right? 150 comma 200, 200 comma 250 will be as it is. Yes, 300 comma 200 will be as it is. And again, if you are coming like this, see, outside to inside, okay, then again the intersection point is saved, which is 150 comma 162. You can calculate it easily with the help of equations. Fine. Depending on the slope you need to calculate, consider x1 y1 x2 y2 like this. Fine. Then go ahead. Fine, for the top edge. Now for the top edge, if you observe, okay, so 300 comma 200 will be as it is, because this point is at right side basically, so this point is not going to change. 150 comma 162 will be as it is, and 150 comma 200 like this. This is the top edge. Then right side you need to clip. After clipping the right side, is there anything in the bottom? No, nothing is there at the bottom. So this is the vertex list you will get after the right edge is extended. Fine. And this whole list is a final list basically. After getting the vertex list over here, what we are going to do? We just need to draw a polygon with the help of vertex again. Okay, this is the another example which is shown here. Fine. So this is about the polygon clipping. So polygon clipping algorithm is simple. It's not that tough. Just remember, you need to apply a line clipping intersection point calculation, whatever we did. Okay, the same way we are going to do it. Fine. So that's all about polygon clipping. Now, what is the drawback? We will see quickly of this algorithm. Okay, of this algorithm. Consider a concave polygon. I will just clear it. Consider a concave polygon. Okay, okay. File, don't save. Yes, I will draw a concave polygon over here. Uh, like this. Okay. Okay. Suppose I have drawn a polygon like this. Fine. Polygon is drawn. Now I want to clip it. Fine. So after clipping, say consider my clipping window will be, this is my clipping window. Okay. So after clipping, actually what is expected, if you observe, yes, the above portion and the below portion is expected, right? But if you go as per the polygon clipping algorithm, consider this edge. I will give a naming, okay, so that you will understand it. A, A, B, C, D, and E. Okay, this is the concave polygon. Okay, if you join any 2 points, then there is a possibility the partial edge is outside. That's the reason. Okay, then see, I started drawing from A to B. Which point I am going to save? Intersection point, that is this particular point, and B point. Yes, I saved it. Go ahead. From B to C, which point is saved? This point is saved. I2. So I1B, I2 is saved. Again, you are coming from inside to outside. Which point is saved? This I3. Okay. I3 is saved over here, right? And next is inside the window, that is D is saved. Again, you are going from D to E. This particular intersection point is saved. Okay. So I will just give naming to the intersection point. So this is I1 intersection point. Okay. This is I2 intersection point. This is I3 over here. And this is I4. Fine. So considering this particular window. Fine. So I1B, I2, I3. I will just write the list. I1, I1, B, I1, comma, B, comma, I2, comma, I3, comma, D, and finally, and I4, I4. Okay, these many points you need to save. These many points. Okay. After clipping, this is my window. Okay. I just move this part. Okay, sorry. Select. Select. Okay, this is my window. So here, actually after clipping, if you join it properly, after joining, how it will look? It will look like this. This. So here, if you observe the extra edge, if you can see here, I will indicate extra edge. See, this extra edge is over here, this particular edge. Okay, this edge is produced over here, basically, which is not expected. This particular portion, I will highlight it. This particular portion, okay, which is not expected. This much portion, this blue line, only blue line. Okay, so extraneous line is produced by a Sutherland-Hodgman clipping algorithm. So this is extra line. Extraneous edge is produced in case of edge or line. In case of concave polygons. Okay, that is the drawback of Sutherland-Hodgman algorithm. That's why new algorithm is designed, and that is known as Wheeler-Atherson polygon clipping algorithm, which we will see next time. Okay, so I hope this much part is cleared for the polygon clipping algorithm.